Hello, my name is Mr. Chipman, and I teach biology and AP Biology at Murray High School in Murray, Kentucky. This is 5.10, Impacts of Urbanization. Let's look at this. What is urbanization? Should be pretty self-explanatory. Here's an urban area. I don't know what urban area this is, actually. I can't just look at a city and tell. No idea what that is, actually. This process of people moving from rural to urban areas. Should make sense, right? Creating these giant urban areas like this where people are stacked on top of one another. For some people, this is their preference, but it does come with costs. Let's talk about a couple of these. And so water use is going to be necessary because people require water in order to stay alive. And particularly in coastal regions that are up against the ocean, there's going to be this thing called saltwater intrusion that happens. This is where when you are pumping excessive groundwater from these coastal areas, what ends up happening is the saltwater starts to intrude into that groundwater aquifer. Because of the decrease of that aquifer, saltwater starts to intrude in that, which is not good. Saltwater is not good for us. It's not good for the environment unless it's a marine environment, of course, but freshwater and saltwater environments don't really mix unless it's that specific ecosystem, right? Like a estuary or something like that. But most of this, where coastal cities are built are not necessarily that. And so this does involve some problems associated with that. Fossil fuel use is a big thing. Because urban areas tend to use a lot more fossil fuels than non-urban areas just because of the density of people. Fossil fuel combustion, particularly for transportation, heating, electricity, all of these are going to be major CO2 emissions or emitters, which is going to increase or impact the environment, especially as an urban area has less trees to soak that excess CO2 in, and it's just going to create problem, smog and other things. Landfills, great example of how an urban area, because all their trash has to go someplace, right? And so you have these massive areas that are just trash, full of trash and video games. If you know the story here, tell me in the comments. Impervious surfaces, not stories. This story is something else, but impervious surfaces. So this is the idea that there's surfaces that water can't penetrate, like asphalt, concrete, great examples. Most cities are just covered in those two surfaces. So when it rains, where's all the water go? Well, it doesn't have a place to go. It doesn't get soaked into the ground. It just goes to other concrete and asphalt places, and that can be bad. That can be bad for people's homes and businesses and all of that sort of thing. You have increased runoff, you have flood risks, you have carrying of pollutants into those areas, things that are on asphalt, typically like oils and heavy metals and all of that stuff. Never good. And this reduces groundwater recharge as well because water's not going into the ground, it's just staying above the ground. It's all going to one place. This exacerbates any kind of vulnerability to a drought, and so cities that are more prone to drought have more issues because of their impervious surfaces. And then there's the idea of the urban sprawl. This picture is fascinating. We could sit and talk about this picture for a long time and all the things that it encompasses and details. Urban sprawl is the spread of low-density suburbs. Low density is this sort of thing where you have homes and that kind of thing, as opposed to this more high-density sort of area where you have people literally stacked on top of each other. And where does the low-density suburb spread into? The rural, natural kinds of areas, places that were farmland and forest are now homes stacked on homes and schools and police departments and McDonald's and all the things that exist in the burbs, right? Habitat fragmentation, biodiversity lost. This is going to increase car dependency, which is going to cause more fossil fuel use and air pollution. Higher infrastructure is going to be necessary, sewers, roads, utilities, all of that stuff has potential to damage ecosystems. the people got to live somewhere, right? They got to live up against the urban areas for some reason. Let's look at some examples of this. Miami is a great example of the water, saltwater intrusion thing that we just talked about. It's not good when you decrease the amount of coastal area aquifers, freshwater aquifers. The saltwater tends to intrude into those, and a place like Miami, that is a large coastal city, has a continued problem with this. Here's a picture of Houston after Hurricane Harvey. Hurricane Harvey caused significant damage to the Houston metro area because the water didn't have a place to go. It just kind of sat there on top of the concrete and the asphalt, which is not good for the people that live in those places. And it was a devastating disaster, and this is a great example of that concept of impervious surfaces. Let's look at this practice problem. Coastal cities expanded rapidly, replacing wetlands with roads and parking lots. After rainfall, residents experienced severe flooding, and nearby aquifers show signs of saltwater intrusion. Which process directly contributed to both these issues? We know the answer. We've talked a whole video about it. Let's look at it. Increased CO2 emissions? Not really. That happens. That's not what caused this. Greater methane released? That happened. Didn't cause this. Expansion of impervious surfaces and groundwater withdrawals. C is the correct answer. I hope this was helpful. 5.11 is coming right up.